So this lesson is section 10.4 on inverse trig functions, not to be confused with reciprocal trig functions. We will be evaluating inverse trig functions and actually using them to solve some triangles as well. Why couldn't the angle get a loan? His parents wouldn't cosine. Aww. Sorry about that. Okay, so if we have a function sine of theta equals a, we'll just reveal these. The inverse would be read as, and you can see here it's sine to the -1. That's the inverse sine. So it's also called arc sine. So, oh, I don't like that color. Can't see it very well. Never mind that. So if you do inverse sine, that would look like that. That would be, you could call that's inverse sine or arc sine. They mean the same thing, just two different names for the same thing. And the important thing about inverse sine or arc sine is it's the angle. Okay, let's do this. Inverse sine of a equals theta. Inverse sine of a, I'm going to need to fix this, sorry about that. Inverse sine or arc sine of a is the angle whose sine is theta. And that's a really important statement. Please write this down, because it can get confusing sometimes what exactly you're looking for. And so if you can remember that inverse sine or inverse cosine or inverse tan, it's the angle that you're looking for. So it's probably easiest if we just go ahead and do an example. So we have here, it says find all possible values of inverse cosine of √3/2. So what we're going to be finding is we're going to find the angle whose cosine is √3/2. Please write that down. I know you might think that's redundant or being, unnecessary, but it's so important to understand what it is you're looking for. So we're looking for an angle whose cosine is √3/2. Now there are two ways to do this. There's using triangles, but our book doesn't use those, and I don't think Mr. Crone does either. So I will go ahead and do it the unit circle way. Now hopefully you have either memorized the unit circle or are in the process. So we're not going to have the unit circle there in front of us. We're going to design it on our own. And I'm just going to use the first quadrant because that's all that's really necessary. And we have our places here. This is going to be pi/6, pi/4, pi/3. And if you memorize the unit circle, you would know that these are the coordinates. If I can only talk. That one barely fits there. And so we want the angle whose cosine is √3/2. Cosine is the x-coordinate. So we look at these x-coordinates and we see that the one that has the x-coordinate of √3/2 is pi/6. So pi/6 is one of the solutions. But remember on the unit circle, because I just drew part of it because that's all I really need, we also have to consider where else, in what other quadrants is cosine positive. Because notice the √3/2 is positive. So cosine is also positive. If you think all students take classes, cosine is also positive in quadrant 4. So if you were in quadrant 4, and whoops, I didn't draw that correctly, did I? Oh yeah, I did. Pi/6, yeah. So if you were in quadrant 4, and this would be if this is a reference angle of pi/6, then if you went all the way around, this would be, 11 pi/6. Oh, goodness. So sorry. So we have two possible places on the unit circle, two possible angles, because we're looking for an angle, remember, whose cosine is √3/2. But that's not the end of the story, because it does say find all possible values. And so we have to include all of the coterminal ones as well. That's not as hard as it might sound. If I am here at pi over 6, and I want to find all the coterminal angles to pi over 6, I would just add another 2 pi to it, and I would get another one, right? And if I added another 2 pi, I would get another one. So we can just add multiples of 2 pi, and the way we write that is plus 2 pi n, where n is an element of the integers. And we use just the z there, that means the integers. So nes means n is an element of the integers. All the positives and negatives. So you could, since z, the integers, could be negative, that also includes going the other direction as well, and getting all of those coterminal angles. And then we'll do the same thing with 11 pi over 6. We'll add 2 pi n as well to get all of those coterminal angles. So, where n is an element of the integers. This entire box thing is all the angles whose cosine is root 3 over 2. Okay, let's do this one. I'll do it together. Again, I'm going to draw the unit circle once again. Get lots of practice with this, right? Because I need them on a new slide here. 11. Oh, you know what else? I need to go back and look at something. Did they want degrees? That's the other thing I just thought of. It doesn't mention degrees or radians. So I like radians, so obviously I just went right to it and did the radian ones. Let's mention over here if, because it doesn't say degrees or radians. If you use degrees, pi over 6 is 30 degrees plus 360n, because 2 pi is 360. And then 11 pi over 6 is 330 degrees plus 360n. So that's how you would have answered if you were doing it in degrees. All right, back to this. So this is pi over 6, pi over 4, pi over 3. We'll repeat the unit circle here. And this time we're looking for the angle whose tan, so I'm going to write that out again, the angle whose tangent is 1. So remember, tan is y over x. And also on here, I'm going to go ahead and put my quadrant angles too. I'm going to have my points here, 1, 0, 0, 1. And we can continue our unit circle out. This would be negative 1, 0. Down here we'd have 0, negative 1. Because you never know, we might need those. Okay, in order to get y divided by x to equal 1, if you look at these points, the only way you're going to get that is right here. Because if you did this y divided by this x, you'd get 1. So that means that the angle we need is pi over 4. So the answer is pi over 4. But remember, we have to include all possible values of tan. So what other quadrant is tan positive in? All students take classes. So tan is also positive in quadrant 3. So if this reference angle is pi over 4, then if you go to here, that's going to be 5 pi over 4. So 5 pi over 4 is another another angle whose tangent is 1. And then we have to add the 2 pi n to each one of these to include all of the coterminal angles. Now something interesting about tangent is, if I put, let's draw, here's the original, the pi over 4. Notice that 5 pi over 4 is just pi over 4 plus pi. So another way you could have written this, instead of writing this all out, all you really had to have was pi over 4 plus pi n. That's special for tangent and cotan, because they differ by 180 degrees, or pi. So, the degree way would be 45 degrees plus 180 n. And then up here, this would be 45 degrees plus 360 n, and that's going to be degrees. Silly me, I have to think about that. That's going to be 180 plus 45. Is that 215? Oh gosh, or 225, isn't it? Yeah, it's 225. You can see why I like radians, because they're faster, in my opinion, to figure out. So if you were using degrees, that would be your answer. You could either answer with the 2, or this one actually would include both of these all in one answer. Oh. Okay, so apparently this is going to be a warm-up. Find all possible values of arc cosine of negative 1/2. Well, I guess I'll skip it then if we want to use that as a warm-up. Which trig ratios do pig farmers use? Huh? What would that be? Haha, swine and coswine. Very clever. All right, let's see what we got going here. Oh, okay, good. For a minute there, I was a little worried. Trig functions with restricted domains are indicated with a capital letter. Yeah, so you know how on the first 2 examples, when we wanted to find inverse sine, we had, or actually all of those, we ended up with a multiple number of answers because it included both quadrants as well as all the coterminal angles, which means that these would not be functions because you put in one x value and we got out a whole bunch of y values. So like to kind of emphasize what I'm talking about, if you go back here, our input was 1, that's our domain, and then our range were pi over 4, 5 pi over 4, and all of the coterminal angles, and there's an infinite number of those. So that means that inverse tan with a little baby t is not a function. This is not a function, because for each input we're getting multiple outputs. But mathematicians, of course, want functions. They're nice. They like them. So they decided to force them to be functions. And the way that they forced them is that they restricted the domains. So, and whenever we restrict the domains, at least our book uses capital S, capital C, capital T. I can't recall, I don't think the pre-calc book does this. So this is, different books do it different ways. Okay, so for arc sine, when you restrict it, it is restricted between negative pi over 2 and pi over 2. So in other words, it's restricted to quadrants 1 and 4. This is very, very important, so please pause this video and write down this entire slide. It's very important that you know this. Then arc cosine is restricted from 0 to pi, which would be quadrants 1 and 2, as you can see here shaded in. And then inverse tan is restricted from negative pi over 2 to pi over 2, just like sine. However, notice on arc tan that there are no equal to's here. That's because arc tan is actually undefined at negative pi over 2 and pi over 2. It's impossible there. Because notice what happens if you do tangent of pi over 2. So remember on the unit circle, this point's going to be 0, 1. And tangent's defined as y over x, which is going to be 1 over 0. Notice that's undefined. So that's why there's no equal to's here, because they don't exist. Okay, so please write all this down, and then we'll go to the next slides, and we'll use this stuff. Oh, actually we have more to write down. So this is saying pretty much the same thing. So again, it's kind of saying it out in words. It's giving us the symbols again. Here's the range we were just talking about. So these are super, super important to memorize. That, between negative pi over 2 and pi over 2 and so on. Now the domain is also interesting because notice the domain of sine and cosine, or I should say arc sine and arc cosine, is between negative 1 and 1 inclusive. So that means you cannot find the inverse sine or the inverse cosine of numbers larger than 1 and smaller than negative 1 because they just don't exist. Now we can take arctan of any number. So down here, notice the domain for arctan is all reals. So please write this down too. This is really important. Please pause this video and write this chart down. we already know that. Okay, finally we get to use it. This is where the rubber meets the road. We are going to evaluate. Now this time it does say to use both radians and degrees. All right, fantastic. So again, I'm going to draw my little unit circle. Of course, you probably have it right there in front of you, hopefully. Pi over 6. Got to get the brain working here. Draw this thing enough times and you're definitely going to remember it. And then of course, all these others, I'll just put these on. We don't need to repeat the entire thing because if we know these, that's enough to figure out the others. So, arc cosine, we want the angle whose cosine is negative root 3 over 2. My goodness, we just did this earlier? So we want the angle, again, I don't mind writing this out again, angle whose cosine is, negative root 3 over 2. So cosine is the x. We come over here. The angle whose cosine is root 3 over 2 is pi over 6. However, this is negative, so really we need to figure out which quadrants cosine is negative in. However, not so fast, because this is a capital C. So arc cosine with a capital C is defined between 0 and pi, so it's only defined in quadrants 1 and 2. Well, we know that the cosine is positive in quadrant 1, so it can't be that one. And sure enough, in quadrant 2, cosine is negative. So our answer is going to be over here in quadrant 2, and the reference angle is pi over 6, so that means the angle that we want is 5 pi over 6. So 5 pi over 6 is one of our answers. We don't have to find the coterminals. In fact, we don't want to, because this is a function. We're only going to get one answer. But we're going to answer that in degrees as well. So this is 30 degrees, and 180 minus 30 is 150. So we could say it's also the same thing as 150 degrees. Okay, these are fun. Let's do another one. Inverse sine of negative 1. Oh, God, what is wrong with me? So sorry. Inverse sine of 3/2. I gotta wake up. It's morning. That might be part of my problem. We want to know the angle whose sine is 3/2. Well, if nothing's coming to mind, that's because it doesn't exist. Remember, the domain here for sine and arc cosine is between negative 1 and 1. Well, 3/2 is 1.5. It's outside the domain. So this is undefined. There is no such thing, because 3/2 is outside the domain. Now, if it was arctan, we'd be able to do it, because you can find arctan of anything. This is a check it out or on your own. So please pause and do this on your own, and then I'll put the results up. So here's my unit circle. And we've got pi over 4. Oh, gosh, I am really getting irritated with myself, making these stupid mistakes. I always put these quadrant ones on here. All right. And you know, once you get really good familiar with your unit circle, the arc sine of root 2 over 2, it's pi over 4. It's obviously right here. But it's negative, so it's not going to be the one in quadrant 1. And then remember, arc sine with a capital S is only defined in quadrants 1 and 4, from negative pi over 2 to pi over 2. So arc sine is indeed, or sine is indeed negative in the 4th quadrant, so we're going to be right here. Because remember, all students take classes, only cosine is positive in the 4th quadrant. So our reference angle is pi over 4. We have to be very, very careful here. We are not going to give our answer as, 7 pi over 4, because 7 pi over 4 is not between negative pi over 2 and pi over 2 on a number line. I'm writing this out because it's really important. Kind of think about the negative pi over 2 to pi over 2. Like if you were on a number line, here's 0, here's negative pi over 2, here's pi over 2. 7 pi over 4 would be out here somewhere. And arc sine is only defined on this portion of our number line. So we can't give our answer as 7 pi over 4. That is not going to work. But we can give it as negative pi over 4. Because negative pi over 4 is right here. And that is in the range. So our answer is negative pi over 4. That's the angle that's in the fourth quadrant, and it's also between negative pi over 2 and pi over 2 on a number line. So we have to proceed with great caution on this one. Notice also they want us to put this into degrees, so that would be also negative 45 degrees. So those are the answers we're looking for there. Oh, another warm-up, so we'll be doing more of this practice in class. Okay, evaluate each inverse trig function. Okay, so we're going to go back to a unit circle. Now I can tell that this is going to be one of the quadrant angles. So to save your time, I'm just going to put these on here. Of course, you have hopefully your unit circle there in front of you with everything. So I want the angle whose cosine is 0. Remember, 0 is the x-coordinate. So there are two angles here whose cosines are 0. But remember, cosine with a capital C, inverse cosine with a capital C, is only defined from 0 to pi. So that means this one down here is out. It's outside of our range. So we are going to give the answer here, it's going to be pi over 2 only, which is the same as 90 degrees in degree, 90 degrees. Okay, we're moving past that idea. I am going to, like I said, I'm going to give plenty of practice in class doing warm-ups so you can make sure we understand those really well. But now moving on to a new example. A painter needs to lean a 30-foot ladder against a wall. Okay, so here's a wall. Here's a 30-foot ladder. We'll label what we know here. We're going to assume the wall is vertical at 90 degrees. Safety guidelines recommend that the distance between the base of the ladder, so that's here, and the wall, so this distance needs to be 1/4 of the length of the ladder. So 1/4 of 30 feet. In other words, 30 divided by 4. To the nearest, so that's going to be in feet as well. To the nearest degree, what is the acute angle? What acute angle should the ladder make with the ground? So here's the ladder, here's the ground, this is our theta. Now you know what? You guys did this last year in geometry, the same exact problem. So let's see, 4 goes into 30, 7.5 times. So let's write that there. And that's easier to work with. Now we had to figure out which trig ratio relates these two sides and this angle, and it's going to be cosine. So we write cosine of theta equals adjacent, which is 7.5, over hypotenuse, which is 30. And the units are the same, so we're good there. And then to undo, we have to solve for theta, so to get rid of theta, or to get theta by its own, we get rid of cosine by doing arc cosine. So what I'm in essence doing here is I'm taking arc cosine of both sides like that, and that cancels. So theta equals arc cosine of 7.5 over 30. We go to our calculator, and we do second cosine, that's inverse cosine, 7.5 divided by 30. Enter. Oh, I get 1.318. What do you think about that? Well, if that seems a little strange, it's because this is in radian mode, isn't it? So if I go to mode, notice I'm in rads. I want to go to degrees since this is a real world problem. Now I can do enter again, and it will give me the answer in degrees. 75.5, and it says to the nearest degree, so that's going to be 76 degrees. So if you're in the wrong mode, hopefully you'll notice it by getting a weird answer. The other thing I was going to say is the difference between inverse and reciprocal. Inverse is the angle whose cosine is whatever, whereas the reciprocal, so the reciprocal of cosine is secant. And the inverse of cosine is arc's cosine. So just keep in mind there's those two words mean different things, so you have to use them correctly. Right, here's one for you to try on your own. Although, you know, I think I'll do it because it's a little different. It's with directions. A group of hikers wants to walk from a lake to an unusual rock formation. So here are the hikers. The formation is 1 mile east, that's this way, and 0.75 miles north. Make a triangle. This is going to be a right angle. To the nearest degree, in what direction should the hikers head from the lake to reach the rocks? So they want this angle right here. We take a look at the triangle. We notice that it is tangent. So tan of theta equals opposite over adjacent. We're going to take arctan of both sides. That's the inverse tan. Inverse tan of 0.75 over 1, which is just inverse tan of, of 0.75. So back to our calculator. Inverse tan, which is second tan. I think I forgot to mention the inverses were second. Second tan, so that's inverse tan of 0.75. And this time we are in degrees, 36.9 degrees. And then the way to answer this is that that's going to be 36.9 degrees north of east. I do think that is how that book says it. I should probably double check. Let me just check here real quick in the book. Yeah, that's how they said it. And we're on the last one. Solve each equation to the nearest tenth. Use the given restrictions. Okay, so we've got sine of theta equals 0.4, or 0.4. And 0.4 is not one of the values on our unit circle. So we are going to be using our calculator. We're going to be taking inverse sine of both sides. So we do this. We go to our calculator. Second sine of 0.4. Enter. 23.58. But don't stop there. Look up here and see and make sure that our answer is in the interval that is given. And yes, 23.58 is between negative 90 and 90. So we don't have to worry about anything else. We did it. Okay, same problem, but this time we're restricted from between 90 and 270. So I already know that theta, when I go to my calculator, what was it, 23.58, that I got theta equals 23.58 degrees. Well, that is clearly not between 90 and 270. But because we know these things are cyclic, we can figure this out. So 23.58 degrees would be right here. That's the given answer. And notice 0.4 is positive. So what other quadrant is sine positive in? All students take classes. Sine is also positive in quadrant 2. So I'm going to go ahead and plot my reference angle there as well. And then my angle that's going to be between 90 and 270 is going to be the angle that starts on the initial side and goes to here. So to figure out that angle, I know from here all the way to here is 180. So if I do 180 minus 23.58 degrees, I'll get this, the angle that I want, which is from here to here. So 180 minus second answer is 156.42. That is between 90 and 270. Please draw pictures. See how the picture helped me figure this out? So I highly encourage you, draw pictures. Make sure you look at the restrictions. Don't just quickly find inverse sine and go, and stop. You've got to look into this a little more deeply. Here's one for you to try on your own. And I'll go ahead and do it too. So I'm going to be doing inverse tan, or here I'll write the problem down. So theta is going to be inverse tan or arctan of -2. Remember, I can take the inverse tan of any number because its domain is all reals. So inverse tan of -2. I get -63.43. Okay, that's okay. That's between -90 and 90. That one. Then on the next, I do believe they're going to have a different restriction from 90 to 180. So let me come back. 63.43 negative. -63.43 degrees is what I'm going to get when I put that in my calculator. The calculator is going to give you that value every single time. The calculator is not going to tell you the angle between 90 and 180. We have to figure that out by drawing a picture. So I'm going to draw -63.43, that's down here. And this is negative, so where else is tangent negative? All students take classes. Tangent's also negative in quadrant 2. So I'll draw in my reference angle there as well. Remember, this is the reference angle. So my angle between 90 and 180 would be the angle that has initial point on 0 and goes to here. Because here's 90 and here's 180, and that angle would fall between those two. So to get that angle, again, this is 180. So I'm going to be doing 180 minus 63.43. And that will give me the angle I'm looking for. 180 minus 63.43. 116.57. That angle is between 90 and 180. That concludes the lesson, and hopefully it's made some sense. Notice too that some of these examples are different than the ones in the book. So if you need additional examples, you can look at the book and work through some of the ones that they did in there.